Hey everyone, welcome back. Today we're going to talk about complex numbers. Complex numbers are in the format a plus bi, where a is the real part and b is the imaginary part. And the letter I is the imaginary unit. So I is equal to the square root of -1. So previously we couldn't take the square root of a negative number. We would say it wasn't real. Well, now we're going to look into what a square root of a negative value is, and it's imaginary. So whenever you take the square root of -1, you get this letter I. And if you have the square root of -a, where a is any other value, you can pull out that imaginary component I, because -a is the same as -1 times a. So if you take the square root of that, you'd take the square root of -1 times a, or the square root of -1 times the square root of a. And since the square root of 1 is I, that's how we get I times the square root of a. It allows us to pull that imaginary part out. So let's use I to rewrite the expression square root of -12. Well, the square root of -12 is the same as -1 times 4 times 3. Or it's the square root of -1 times the square root of 4 times the square root of 3. We know we can take the square root of -1, that's our imaginary number I, and we can take the square root of 4, that's 2, and the square root of 3, well, 3 is not a perfect square, so it stays as the square root of 3. And the proper way to write this is to put the real number, then the imaginary, and then the square root. So it would be 2i square root of 3 is equivalent to the square root of -12. Now, we can do other operations with complex numbers. We can add and subtract complex numbers, and we can multiply complex numbers. When we add and subtract complex numbers, you first add and subtract the real parts, and then you add and subtract the imaginary parts, because you want to end up with the real parts separate from the imaginary parts. And then when you multiply complex numbers, you're just going to use FOIL. But you need to remember that I squared equals -1, because whenever you FOIL, you might have an I times an I, or I squared, and you need to simplify that to -1. Let's look at these examples. We need to write the expression in standard form. That means a plus bi. The first example, we're adding. We have 2i plus -8 plus 5i. So we can rewrite this without parentheses. Now we need to add or subtract the real parts. Well, the only real part we have is -8. So that stays as -8. And then we add or subtract the imaginary parts. And imaginary, we have 2i plus 5i. Which is plus 7i. So our simplified format here is -8 plus 7i. And this is in standard form because it has the real part plus the imaginary part. Now in example 2, we have two binomials, so we're going to use FOIL. So we multiply the first terms together, so 3 times -1. Then the outer, which is plus 3 times 5i. Then the inner, -1 times 2i. And then the last terms, plus 2i times 5i. Now we do the multiplication. 3 times -1 is -3. 3 times 5i is a positive 15i. -1 times 2i is a -2i. And then we have plus 2i times 5i, which is plus 10I squared. Now we want to start combining our like terms. Negative 3 doesn't have anything to combine with yet, but terms 2 and 3, 15I and negative 2I, simplify to plus 13I. And then that last term, plus 10I squared, well, remember, I squared is negative 1. So this is plus 10 times negative 1. So we simplify a little further. Negative 3 plus 13I. 10 times negative 1 is minus 10. Now we have another real number, negative 10, that needs to be combined with the negative 3. So we get negative 13 plus 13I. Now it's in standard form, a real number plus an imaginary part. Let's go to page 2 and look at a couple more examples. So example 1 here, we're multiplying two binomials together. So we use FOIL again. First, 5 times 5. The outer, negative 4I times 5. The inner, a positive 4I times 5. And the last, a positive 4I times a negative 4I. 5 times 5 is 25. Negative 4I times 5 is negative 20I. 4I times a positive I is a positive 20I. And 4I times a negative 4I is negative 16I squared. We'll notice that these two middle terms are going to cancel each other out. That's because if we look at the original binomials, this was actually the factored form of a difference of squares. So this simplifies to 25 minus 16I squared. But we need to simplify that I squared, right? I squared is the same as a negative 1. So we have 25, negative 16 times negative 1 is plus 16, and 25 plus 16 is 41. So this multiplied out and simplified to just a real number, 41. Now, example 2, there are parentheses, but if you look closely, we're just adding and subtracting. So let's remove the parentheses and distribute any signs we need to distribute. Well, we have 3I, and then we're adding what's in the second set of parentheses, so we just keep their signs. And then we're subtracting what's in this set of parentheses, so we need to change the signs. So distribute the negative, we get negative 1 and plus 5I. Now we just combine our like terms. Remember, we want to add all of the real numbers together first, so that would be 2 minus 1. And then we need to combine our imaginary numbers, 3I minus 3I plus 5I. So now that I've grouped them together, we can easily simplify. 2 minus 1 is 1. And with the imaginaries, 3I minus 3I, that's 0I, plus 5I is just plus 5I. So this simplified to 1 plus 5I. Now, occasionally, you'll multiply imaginary numbers, and you'll have i's with exponents that are larger than 1 or 2. And that's where knowing the powers of I comes in handy. If you have I to the power of n, you're going to take that exponent n and divide it by 4. The remainder left from that division tells you how to simplify I to the n. You simplify it as I to the r, whatever that remainder was. And it will fall into one of these 4 categories. So I to the power of 0 is 1, because anything to the power of 0 is 1. I to the power of 1 equals I. That's the identity property, right? Anything to the power of 1 is itself. I squared, as we saw earlier, is negative 1. And then I cubed is negative I. Let's look at these examples. So we have I to the power of 58. We could go back to this rule of I to the 0, I to the 1, and so on, and keep on writing it out until we get to I to the 58th. Or we can take 58 and divide it by 4. 58 divided by 4. 4 goes into 5 one time. And we have 18. 4 goes into 18 4 times. That's 16. And we have 2. So our remainder here is 2. That means I to the power of 58 is equivalent to I to the power of 2, or I squared, which means I to the power of 58 is negative 1. Now look at I to the power of 64. 64 divided by 4. Well, 64 divided by 4 is 16. And the remainder is 0. So I to the power of 64 is equivalent to I to the power of 0, or just 1. So you divide that exponent by 4, and whatever the remainder is from division tells you the corresponding exponent. Now, what if we divide complex numbers? Well, remember when we just divided with radicals and we couldn't have a radical in the denominator? The same applies with complex numbers. We can't have an imaginary number in the denominator. So we need to multiply by the conjugate in order to eliminate that imaginary number from the denominator. So here we're asked to write this expression in standard form. Standard form, remember, means a plus bi, where you have a real component and an imaginary component. And since we have an imaginary number in the denominator, we're going to multiply by the conjugate. So remember, you keep both of the terms and you change the sign in between them. So because it was 5 minus 2i in the denominator, we're going to multiply by 5 plus 2i. And if we do the same in the numerator, we're multiplying by 1. Now remember, since we're multiplying 5 minus 2i times 5 plus 2i, this is really a factored version of the difference of squares. So it's going to cancel out that middle term. So let's do the multiplication. Here we would get a numerator of 3i times 5 plus 2i. And our denominator would be the binomial 5 minus 2i times the binomial 5 plus 2i. In the numerator, we just have to distribute. So 3i times 5 is 15i, and 3i times 2i is 6i squared. Now, in the denominator, we're going to FOIL. And you'll see that those middle terms are going to disappear on us. So first is 5 times 5, which is 25. And then outer is 5 times 2i, which is plus 10i. Inner is 5 times negative 2i, so minus 10i. See, they're going to cancel out. And then last is minus 2i times positive 2i, or minus 4i squared. Now, these middle terms in the denominator cancel each other out. Our numerator is 15i plus 6i squared, but i squared is negative 1. And our denominator is 25 minus 4i squared, which again is minus 1. So let's keep on simplifying. This becomes 15i minus 6 in the numerator, and the denominator would be 25 plus 4, or we have 15i minus 6 over 29. Well, remember we need an a plus bi, so we can rewrite our numerator as negative 6 plus 15i over 29. But still, it's all contained in one fraction, and we need to have two distinct parts, a real part and an imaginary part. So because the denominator is one term, we can separate each of the numerators into two fractions. So remember, this would be negative 6 over 29 plus 15 over 29i. And now we have that a, our real part, plus our bi, our imaginary part. Have a question or a problem you want help with? Leave it in the comments and I'll include it in one of my videos. If this video was helpful, subscribe to my channel for more math tutorials. Thanks for watching. See you next time.